Now let's talk about the case when the derivative does not exist. The derivative of a function is defined by the limit of this given expression here. So that means that the existence of the derivative at x equals a depends on the existence of a limit at x equals a. So if the limit does not exist at x equals a, we say that the function is not differentiable at x equals a, or f prime of x does not exist. So when does this occur? When will a function not differentiable at a given value of x? Now recall that for a limit to exist, the left-hand limit has to be equal to the right-hand limit. And since derivative uses limit in its definition, that means that for the derivative of the function to exist at a particular value of x, the left-hand limit at that point has to be equal to the right-hand limit. Now your next question would be, when will the left-hand derivative is not equal to the right-hand derivative? That occurs in a situation where you have a corner point, like in this case here. In this case, at x sub 1, at that point, at the left-hand side of x sub 1, the tangent line at that point will look like this. But at the right side of x sub 1, the tangent line will look like this. So notice that this tangent line here, this line here, has a positive slope, while this line here has a negative slope. So in these cases, the slope from the left is not equal to the slope of the slope at the right. So that means the left-hand derivative is not equal to the right-hand derivative. So therefore, the limit does not exist at these points. So when you have sharp edge or corner point, there is no tangent line possible at that particular point. And here also, at the end point of the interval, there's no tangent line possible here because the function after this is not defined, not continuous. It's not continuous at x sub 3. And also, at this given point here, the derivative does not exist because the limit does not exist at this point. And at this point, the function is actually undefined. Moreover, a function is also not differentiable at the values of x for which the vertical asymptotes occur. So if you have a vertical asymptote at that particular value of x, your function is not differentiable at that x. And lastly, a function is not differentiable to the point where a vertical tangent line occurs. So to sum this up, if you're looking at the point and the function is discontinuous at that point, then automatically the function is not differentiable at that point. Now, whereas if the function is continuous at the points, but a corner point or a sharp edge occur at that given value of x, function is not differentiable. And also if there is a vertical tangent line at that point, the function is also not differentiable. Now consider the graph here. Find all points where the function is not differentiable or the derivatives does not exist. First, we look at the points for which the function is discontinuous. Take note that if the function is discontinuous, automatically the function is not differentiable. So in this graph here, the function is discontinuous at x equals -5. And also, it's discontinuous at x equals 0. So therefore, at -5 and 0, the function is not differentiable. Next, we look at the point where there is a corner point or a sharp edge. The x values where we have a sharp edge is at 1, 2, 3, at -3, so x equals -3, and also at this point here, which is x equals 2. And lastly, the point for which there is a vertical tangent line, the function is also not differentiable at that point. So the point on the graph where there is a vertical tangent line is the point 1, 2, 3, 4, x equals 4.